Okay, let's get started. Could you see my screen?
Yes. Yeah.
Okay, great. Yeah. Uh, Everybody, you know that last class we started talking about the Fourier transform technique to circuit problems, and I think we discussed two problems, and like you all are facing little bit difficulty in understanding this one. So today again, please look couple of problems, and then I believe you all will be fine. Uh, so for example, everybody see this problem, find the response I naught t. This means this one of the following circuit. This is the circuit. If the input voltage Vt has the Fourier series expansion as follows. This means it says that Vt is this function, 1 plus sum of n 1 to infinity, this whole function applied here. Then based on that, find out I naught t. What current is flowing through that 2 Henry inductor? That's the question. So this means that, like first everybody understand this one. This means because there are two parts, one is the DC. This is the DC voltage. So question is that if you apply 1 volt DC here, then what should be the current I naught? And next, if you apply this function, so here you need not to be worried by looking this on, don't worry at all. Everybody look, this is the magnitude. Like take in that way, like V equal to Vm cosine of omega t. Therefore cosine, this argument, this is the omega t plus theta. So therefore see, tan inverse 1n, this is the theta angle, 10 degree, 15 degree, whatever. So n omega t. So in this case, omega value is 1. And so this is just the simply magnitude, let's say 100 or 200. So therefore think in that way, that first you are applying 1 volt, then what should be your current? Next time you consider this function here, and then what is the corresponding I naught? And then you just sum up those two. That's all. So that you have to do, and then that is the difference between this chapter and the other chapter. So therefore, I believe everybody can solve this circuit. So because you have to find out I naught t, whatever this function or this function, first, I mean generalized it, because you have to find out this current. If you know what is your total current, what is the IT, then you can find out what is the current I naught t by applying the current divider rule, right? So therefore, what is the first step? First step, you can find out what is the equivalent impedance or what is the total impedance of the circuit. So you see that is also easy. This is 2 ohm resistance, 2 ohm resistance. So 2 plus 2, 4. That 4 ohm is in parallel with this 2 Henry. And this combination is in series with 4 ohm. So that you all know. And once you get that total impedance, then find out what is the total current. This voltage divided by current. Now you will be doing that in two steps. First, if this is the voltage, then what? And if this is the voltage, then what? And that's all. So, and then once you get the total current, and then apply the current divider rule here, that I naught is I multiplied by this 4 divided by 4 plus 2 Henry equivalent impedance in phasor form. So that's why everybody see like what I am doing. First I wrote those things. We see that omega naught on radian per second. So how I know that? By looking this one. You see, cos n omega t, because omega is not given, meaning that omega value is 1. So that's why I have written omega naught on radian per second. But in generalized format, you can say this n, this is the omega n, omega subscript n for generalized function because n equal to 1 to infinity. So that is in radian per second. because I mean in the previous class we noticed omega n is n omega naught. Here omega naught is 1 because nothing is multiplied with n. And then you say everybody look, next time I am finding the total impedance capital J, which is this 4 plus 2 plus 2 is 4, which is in parallel. This is parallel sign. J 2 omega n, for 2 Henry, the J omega L that you know. But in this case, J omega n and then 2. So that's why I have written J 2 omega n. Omega n is this one, generalized nth term with nth harmonic of the omega. And then you say simply I am this multiplied by this plus this parallel combination. And then I am doing. I got this one. And once I got this one, this means this is the total J. And then now you come back. So first you find out total current. I am doing in phasor form, as you can see. So that's why I'm using capital I, capital V, capital J. Here those are the time function, time domain. I not T. I mean at last we have to convert into time domain, but right now I am applying the phasor domain. So therefore everybody see I is V over J. This is B. What was the J? This was J. So that's why it is in the denominator, but then 2 plus j omega n, I put in the numerator. So therefore, I think everybody understand this one. After that, you see, I am applying current divider rule because this is my interest. I want to find out this current. So that's why I not capital I, this is my total current here. So that total current multiplied by this impedance, 2 plus 2, 4, both are resistance. So there you see 1 multiplied by 4 divided by 4 plus j2 omega n. And then substitute the value of I. This is the I value. You see, I am substituting this one here. So I got this one. After that, I am just simplifying. You simplify. So finally, I got I naught V over 4 multiplied by 1 plus Jn. So this is my generalized. Now you see there is V. This V means this source. Now that you have to consider twice, this is your general format. First you consider if V is 1, then what? And if V is this, then what? What is the I naught? And then you just sum up. That's all. So everybody, could you follow the up to now? Or if you have any questions, confusion?
Good.
Everybody is fine, these things so far? So up to now, like this is, you already know. So I think everybody should be fine up to now. So from now on, you all notice. Now I am going to that next one. Okay, now what I am doing, everybody look, I am writing for DC component, V is on volt. So why I am telling that? Because I am considering this one. You see, that was my VT function, VT. So if VT is, sorry, this one, for DC component, what I did, before that, I little bit further simplified. Everybody see the very last line. It was I naught V over 4 1 plus Jn. So that's why I am taking the magnitude of this one. I am expressing 1 plus Jn into polar form. So magnitude will be root over 1 square plus n square. And then angle would be tan inverse n over 1. This means tan inverse n. Just think about the magnitude of it with the angle. So that I did at first. V over 4 root over 1 plus n square tan inverse n. And then for DC component, V equal to 1 volt. So therefore, because it is DC, this means that n value is 0. Because n is for the harmonic. When there is frequency, N1 means when it is fundamental frequency, 60 Hertz. N2 means frequency is 120 Hertz, 60 multiplied by 2. So because I am considering DC, whatever the voltage is, V is on, but N is 0. So this means that you see, I am doing this one for DC onboard, I not V for N0, just root over 1, angle tan inverse 0. So therefore, what I am getting, simply it is 1 over 4. And then that makes sense. Even if you don't do this on, everybody understand. Everybody look, if V is on volt here, which is DC, for DC, what is the circuit? Inductor will be short circuited, right, for DC. And if it is short circuited, then what is the value of current I naught? So therefore, all the current, total current will flow through only this short circuit. No current will go through this path. So this means your V is on volt, so 1 divided by 4. This will be only your impedance in the circuit because this portion is short circuited. So 1 over 4, that will be your current. Everybody, could you follow me what I'm saying?
So
Yeah,
you're
that makes
saying
sense.
the
Yes.
first component in the series is like DC biasing?
Yes. So therefore, this is, as you see, I said that response has the Fourier series expansion. For example, there is a function like rectangular shape or triangular shape. For example, this type of function, or even it could be any other type of function or this type of function. There is a function, and then you analyzed it. And then you got this type of expression. That is the meaning of the expression. If the input voltage, Vt has the Fourier series expansion. That's why, because you are looking one, so this is the DC offset. So Julian, like you are absolutely right. Here it expressed because it is one, there is no sine or cosine component. Definitely, this is not the sinusoidal function. So therefore, simply like DC voltage. So DC offset. So you are absolutely right. Is this fine, Julian?
Yes, sir.
Yes. So you fully understood, properly understood. That is the goal of the Fourier series. With the Fourier series, for example, at your home, you have a load, for example, air conditioning load, yeah, and that is consuming power. You are looking the voltage or current profile, and then you might get that no, it is not pure sinusoidal. There is some harmonics in it. And then if you analyze that current with the help of Fourier series, then even you might see this type of representation. So even at your home, everybody's home, if you really analyze, you might see this thing. Because at your home, most of the loads are nonlinear. Refrigerator, air conditioner, washer dryer, television, most of the loads at our home are like nonlinear load. So they do not represent the pure sinusoidal waveform. And really, if you analyze, you might see this type of waveform. So that's why, yes, so this is DC offset. And this is the, sinusoidal because it is cosine. So this is cosine function. Okay, so therefore everybody understood the DC part. Now what I am doing for nth harmonics. For nth harmonics, what is the V? V is this one. So how I got that one? Everybody say, look this one. Like this is the magnitude. Assume that this is V equal to Vm cosine of omega t plus theta. So everybody, you just take in a general form. V equal to, this is Vm magnitude cosine of omega t plus theta. So how, this is the time domain function. How could you write in phasor domain? So this magnitude and just angle, magnitude angle tan inverse n, right? So that will be the your phasor form. So exactly I am writing that on. I am saying for nth harmonics because that is the harmonic term. That is not the DC. V is that one. And then you plug in, everybody say, you plug in this way into the I naught equation. That's all. So therefore everybody look, I am plugging this on here. So what I am getting, I naught, first this one, I did that one, then fully I wrote that thing, then multiplied by What I had 1 over this term. Exactly, I wrote this thing. And then everybody see, I am simplifying. Tan inverse n cancelled. And what I am getting, this is 2, here 4. So I am cancelling. I am getting 2 in the denominator. And then root over 1 plus n square, root over 1 plus n square, 2 1 plus n square. And then angle is 0 because tan inverse and cancelled. So just 0. And then minus 1 to the power n. So I am done. That was my question. Question was find out the response of I naught t. So I am done. I got the I naught t in phasor domain. Now you just convert into time domain. So this means that everybody say, now this is on I naught, but with respect to nth harmonics due to this component. And for 1, we already calculated, we got which is 1 over 4. Now you sum up. I notice this plus this one. So that's how everybody look. Now I am writing in time domain, I naught t 1 over 4th, this one. And then this thing expressed into cosine because you are going back from phasor form to time domain form. For example, you got Vm angle 0 degree. So how to write that? That magnitude cosine of omega t plus 0. So in this case, just cosine of nt. And why I wrote nt? Because by looking this one, this was my omega nt. And then now there is no angle. I got initially it has that phase angle tan inverse n, but really after calculating, because I got 0 degree, so I don't have anything, just cosine t. And then because this is the nth term, this one, so that's why I put summation n on to infinity. This is my answer. I am done. Do you understand, everybody? So is there any place that you are not understanding? Anybody? Are you all looking this on?
Yeah, I think I got it.
Yes, you see. So therefore, I mean, it is not difficult, just a little bit like long calculation, and you have to do a little bit carefully, attentively. I mean, therefore everybody say, therefore this function, look, this function is given here, but you cannot, if you consider one at a time, then you cannot do, because this is the DC offset. It has no frequency, but it has frequency. That is the problem. I mean, simultaneously, like we are dealing with DC plus AC. Then what? That is the challenging part. That's what first we are writing what I need. I need I naught. So here I just that one. Okay, I naught is this one. This is generalized for considering nth harmonic. That's why omega n, omega n, omega n in that format, nth format. This is general. Everybody understand. And then you go back there. What is my voltage? This is my voltage. And this is my voltage. And that exactly I am doing. So, and then ultimately you got this plus this. I did not write that line. And then I am just converting into time domain the way you did in phasor analysis. So that's all. So is everybody fine? Should I move forward?
Yeah.
Yeah. So therefore, I mean, if you just look carefully, then you will see, no, it is not that much difficult. Just it is the mixture of DC and then harmonic. That is the new thing that you have not done before. That is only the new thing we are doing in that way. And that is the objective of the Fourier series, that decompose analyzing a function into multiple components, DC, and what are the sine function and cosine function, and what are the higher order frequency term. That's the goal of the Fourier series or Fourier analysis. Okay, therefore everybody see another example, and then I think you will be gradually fine. See another example. different type of example. Everybody see, you have a circuit here. The circuit is simple. It is IT, current source, and then there is 10 ohm resistance, 2 farad capacitor. The question is find out VT, or question is determine VT and average power supplied to the circuit in the following figure. But you see, this is the difficult part. If IT is 2 plus 10 cosine of t plus 10 degree plus 6 cosine of 3t plus 35 degree ampere. This means this IT has this format. Again, you see, this IT has DC, DC offset, DC current 2, and then there are two sinusoidal components. But here, so the difference is both are cosine, cosine, but difference you see, T means omega T. So omega is 1 here. But for the next one, you see 3T. This means here omega is 3. And this means this time you have to solve this one in 3 times. First, you have to consider if I have the IT2, if 2 DC ampere is here, then what? Then what is the VT and average power for this circuit? Next, you have to consider this one. Considering omega is 1, then what? And then third time this one, 6. This means omega is 3. And then the magnitude is different, 6, angle 35. Here 10, angle 10 degree. So therefore, I mean, it depends on the complexity of the calculation or how long it will be. It depends on how many terms, how many components are in the input. Like for example, in the previous problem, there are 2 terms. This is 1 DC and 1. So 1 and 2. That's why we did twice for this and this. But for this problem, you have to consider 3 cases. DC case, 10 at an angle of 10 degree, omega 1, and 6 at an angle of 35 degree, omega 3. So you have to consider 3 situations, 3 cases. That is the difference. And then the rest of the thing you can do. Everybody, could you follow me what I'm saying?
Yes.
Yeah. So therefore, I mean, just simply take, I mean, you think in that way, like IT is 2 plus this, that is your current expression. It is divided into 3 components. So you consider one at a time. I mean, first we write a generalized formula of V, and then when you will be doing, you just consider 3 cases. Okay, if my current is 2 ampere here, then what? Then what is my voltage? And keep that calculation. Next time you say if I is this one, but this is time domain, you convert into phasor domain. What will be the phasor domain? 10 at an angle of 10 degree. But you have to keep in mind that omega is 1. Then third time what will happen? 6 at an angle of 35. But you have to keep in mind that your omega is 3. Why I am saying that keep in mind omega 3, omega 1? Because if omega 1, then you have one type of frequency. If your omega value is 3, then you have different frequency. Because omega is 2 pi f. Omega is 2 pi f. So then your omega is 3 here. So this means your frequency is changing. And that is the goal of that Fourier series. So this means again this IT originally has one type of waveform, maybe rectangular, triangular, bell-shaped, whatever the function. With the help of Fourier series, you have got this expression that okay, now this IT looks like this one that has 3 components. Now with respect to those 3 components, find out what is your VT and what is your average power. That's the question. So now everybody see now how I am solving it. First, just I'm writing. So by looking this circuit, what you can say, because IT is coming and these two are in parallel. So if you know what is the parallel impedance, parallel combination or equivalent impedance, that impedance multiplied by this current, that is your VT, right? So that's why I have written VT is IT multiplies by GT, means the total impedance. And then in phasor form, I am writing capital V is capital IG. So this is the very first thing you do that. After that, everybody say, what I am doing? I am finding total impedance for this one. So simply you find out the impedance. So 10 multiplied by, because this is capacitor, 1 over j omega c, 1 over j omega 2 I got. And then divide by 10 plus this one, 1 over j2 omega. And then I simplified, I got this format. And then everybody look, this is my equation Vij. I am substituting z value here. Look, this one. So my V, this I is this I, and then for j, 10 over this one, 10 over that one. But here what I did, everybody look, in the denominator, it was like 1 plus j20 omega. I just took its magnitude and the angle. So root over 1 plus 20 square omega square. So 400 omega square, and angle tan inverse 20 omega over 1. So tan inverse 20 omega. So now this is my generalized V. Now I have to consider one current at a time. Consider this one, then what is my V? Consider this one, what is my V? Consider third component, what is my V? And at the end, you just sum up. Then you are done. So everybody, could you follow up to this one? Is this fine, this portion?
Can you say how you got the 400 omega squared again?
Oh, this one? Oh, so therefore you see it was G is 10 over this one, right? So therefore I am substituting this one in this equation actually. So therefore what I am getting V 10 over this one and then G, I. But then I am calculating, for example, this is the rectangular form, right? This is rectangular form. I am converting into polar form, 1 plus j20 omega. But because omega is omega, so it does not have value. So you will not get directly a number if you use calculator. So that's why I am using the normal method, like triangle method. This is x-axis, y-axis, and then j. Like 1 is your base, and then 20 omega is your vertical axis, and then you find out the g. So that's why root over. So how to find out that one? Root over 1 square plus 20 omega squared. So 20 multiplied by 20 is 400. And then omega got omega square. And then this one, tan inverse 20 omega over 1, which is tan inverse 20 omega.
All right, thank you.
You get it?
Yes, thank you.
Yeah. Like, or simply you take a number, for example, 3 plus j5, just an example. So how to do that? Root over 3 square plus 5 square. I mean, for example, you have a triangle. So everybody, just a moment, hold on. Let me do a little bit. For example, what I am doing this thing. I am explaining this thing. For example, this is your R. This is your Jx, because this is perpendicular, and this is your G. And what is that G? G is your root over R square plus X square. So because like, and this is your angle theta. Think about this one. This means my vector J is this one. This is my vector or the impedance R plus Jx that I wrote. But what is the magnitude of J? Actually, this is the magnitude of J. That is that root over R square plus X square. And what is that angle theta? Theta is that tan inverse that X over R. That is your theta, magnitude of or angle of the theta. So because you know that tan theta is that perpendicular over base. So exactly I am doing that thing there. So you have this type of expression, I think it was 1 plus j20 omega. Sorry, it was 1 plus j20 omega. This one. So therefore, see this one. You find out the magnitude. So root over, this is your r, this portion your jx. Therefore, see root over r square plus this one. And then angle was tan inverse this over this. So exactly I did that thing there. And then that actually you do in your calculator when you convert from polar form to, sorry, the rectangular form to polar form. Actually you do these things. You directly get it from your calculator, but actually this is the basis of that. The same thing from the polar form to get the rectangular form. You have to use this strategy. That is the thing you do at one step in your calculator. So is everybody fine?
Yes, thank you. That makes a lot more sense.
Yeah. No, like I'm just trying to make you all understand. So everybody. Okay. So great. Let's go back. Okay. Now that I did, and I just wrote in online. So I should have been written one more line. First, just write 10i over this one, but I just wrote in one step. Root over 1 plus 20 square 400 omega square. Okay. Now everybody see, this is my general way that I am interested to find out. I mean, at last I will convert into time domain. Now I am in phasor domain. Now everybody say, what I am writing? I am writing for DC component. What is the DC component? Now you just look this I, because 10 over this one, this is just a number. This is a magnitude. Now your concentration is on I. So what is my I? Everybody see this one? My first I is 2, but this 2 is DC current. So that's why what I am writing for DC component, omega is 0. That you all know for DC frequency is 0. So therefore, everybody, when my I is 2, put you I2 here, that I am doing here, V is 10 multiplied by 2, but then simultaneously put omega value 0. You see, that I am doing. So this part is 0. So root over 1 plus 0. Tan inverse omega is 0. So angle will be 0. So therefore 20 over 1. So 20 volt. Everybody, could you follow this one? Does this make sense?
Yes.
So this is one thing that you look for DC component omega 0. I put omega 0 here, and when I is 2 ampere, just look from your general viewpoint. Everybody come back. If you have 2 ampere current, look, you have 2 ampere current. So this is DC current. So for DC current, capacitor will be open circuited, right? So therefore no current will flow through the capacitor. The 2 ampere current will flow through the 10 ohm. So what is the voltage? 2 multiplied by 10, which is 20 volt. And exactly that also makes sense. Is this fine, everybody? So I mean, I am just verifying the result, that whether I am right or not. You are right. You are checking. That's why, because I is 2 ampere. This is 2 DC. For DC, what is the voltage here? 2 multiplied by 10, because this is open circuited. So therefore, full 2 ampere current is flowing here. So 20 volt. That makes sense. That I got that one. Okay. Now everybody come back the second term of the current. This is your voltage expression. You got on result, which is 20. So next time I will consider this one, third time I will consider this one, and then whatever I will be getting, I will sum up. That's all that you have to do. So everybody see, what is this one? I value in phasor form, 10 at an angle of 10 degree, you see. So that I wrote here, I is 10 at an angle 10 degree. When it is? For when it is omega is 1 radian per second, because you see omega t, this means omega is 1 here. So that is my now condition. Previous case, my condition was that I is 2 ampere, but what was the frequency? Omega was 0, because it was the DC term. Now what is my new condition? My new condition, this is my I, 10 at an angle of 10. And what is the frequency condition? Omega is 1 radian per second. Now you use this condition into this equation for I. So that I am doing. Everybody look, this is 10 over this one, and then I value is 10 at an angle of 10. And because omega is 1, so everybody look, if I put omega 1, then on plus 400, that I wrote on plus 400, and angle is tan inverse 20 multiplied by omega 1. This is my omega 1. So tan inverse 20. So if you simplify it, you should be getting 5 at an angle of minus 77.14 degree after operation. Because if you do tan inverse 20, if you take it in the numerator, and then you should be getting this angle. So I got V is this one. Everybody, could you follow me what I did here? So this portion is with respect to the second component, second term, because that is your current. You assume that that current applies here. Then what? That is the meaning of this portion. Then you consider, okay, you have the third term, which is 6 cosine of 3t plus 35 degree. That is your third term. Now everybody see that I am writing here. Okay, look, when omega is 3 radian per second, what is my I? My I is this one. 6 magnitude and angle was 35 degree, this one. And the omega was 3. That I am doing. So this one, and then again you put in that equation, you put, now this time you see everybody, because omega is your 3, sorry, because omega is your 3, if you put omega 3, it will be 9. So 400 times 9. And here tan inverse 20 times 3 is tan inverse 60. So that's how everybody look, that I did. Root over 1 plus 400 omega is squared 9, so tan inverse 60. And then if you simplify this one, you should be getting approximately 1 angle minus 54.04 degree. So you are done. You calculated for all 3 voltage, for all 3 terms. So this is 1, and then previously you got 1 for DC component, 20, and you got 1 for this component, second component. Now you just sum up 20 volt plus this one plus the third term. And then you write in the time domain that I am doing here. Therefore, in the time domain Vt, that 20 volt is the DC. This is the second term that I got here. You see, 5 at an angle of this. This means 5 of cosine of omega t minus this one. I mean, just this is phasor form. You write in time domain 5 cosine of omega t. And just omega is 1, so you don't need to write even omega, just t minus this one. So everybody see, exactly I wrote this one, 5 cos t minus that one. And then you write the third term that we got here, 1 cosine of, but this is with respect to omega 3. So that's why I'm writing omega t 3t minus this angle. So therefore for voltage I am done. That was my question. What is the voltage corresponding to this current? So by considering 3 cases, I got what is my total voltage in time domain. Could you follow me? So do you have questions, comment? Then you please stop me. I will repeat and repeat, go back. Everybody, are you understanding?
Yes.
As I said, I mean, not difficult, but if you look carefully, then you will not be lost. Is everybody fine? So if you have questions, confusion, anything, that why we are doing 3 times and what we are doing. Okay, so therefore I am assuming that like all are fine. So we got Vt, but then there was the second portion of that question that determine the Vt and average power supplied to the circuit. So I am done with the voltage, and then major portion I am done. Now I have to calculate the average power. So therefore, everybody see, first I am writing down that average power supplied to the circuit. I am first writing general equation phi. Because I have the DC component, I have the DC here. In the current, I got the DC. Finally, in the voltage also, I got the DC term 20. So I am writing phi VDC IDC. Just think about the DC circuit. How do you calculate the power? Just voltage multiplied by current. So VDC multiplied by IDC. This 20 is your VDC. You see that I put. What is your IDC? Your IDC is 2. What was given. So that I am doing. So first part is done. And then everybody remembered I am calculating average power. So I am writing average power equation half Vn in cosine of theta n minus phi n. This means you remember the equation, power equation, when we are discussing the AC power calculation, average power expression, when you are using the magnitude, this magnitude of voltage and current. So, and then there is on half, and I put sum of n1 to infinity in general format. So, because here we have two terms, this is one term, this is another term for voltage. Similarly, we have second term from current with omega 1 and omega 3. This means there is multiple terms. Even there can be other terms, in this case, like only 1, 2, 3 terms. So that's why I'm writing in general form. And then what is the meaning of that equation? If you remember that power calculation chapter, this have Vn, this means magnitude of V. Now I am dealing with this term and corresponding current second term, this one. Look, everybody, this one. So current magnitude is I, which is 10, and my voltage magnitude here is 5. So have V5, this is current, and then meaning of this one, cosine of voltage angle minus current angle. Next one is the current angle. If you remember when we discussed, few weeks back, the power calculation for the AC circuit. So cosine of voltage angle, which is minus 77.14, minus, if you see the current angle corresponding term, current angle was 10 degree for this term. So I put that on. And then now go the third term. Third term is half. What is the magnitude of voltage? 1. What is the corresponding current? Corresponding current was here, this one, 6 magnitude. So 6, that I do. And then cosine of voltage angle minus 54.04 minus, what is my current angle? Current angle was 35, this one. So that I am doing that one, minus 35. And then if you just use your calculator, cosine, you should be getting 41.5 watt. So you are done, average power calculation. Just you see what you are doing, because you are applying the Fourier technique and you are considering all terms, all frequency component, when omega 1, omega 3, you have 3 terms. Just you have 3 terms. You see, this is first term from DC. This is the second term corresponding to omega 1. This is the third term. And you are like point by point, frequency to frequency you are comparing. This is voltage DC. You multiply by the current DC too. So first part is done. And then think about the second part. When omega is 1. This is my current expression. So 10, and my frequency is this, and then this is my 10 degree. And look the corresponding voltage term, this one. This second term correspond to that current. So just to compare this term and the corresponding term. This is your third harmonic component. So you compare with the third term of the current. So that's all. And then here I am showing the alternatively, instead of doing the power calculation in that way, everybody see, you are done. You can conclude here, but I am showing the alternative method of doing this. The average power absorbed by the resistor is given by. Now, because this is your circuit, everybody see, this was your circuit, and you are asked to find out the average power. So You see, because this is a capacitor, capacitor will not consume any power, that you know, right? So power will consume only by the resistor. Because in case of capacitor, like VI cosine theta or equation, but cosine theta is 90°. If you remember what is the voltage and current relationship across a capacitor and inductor. So in both cases, the phase angle is 90°. So the average for VI cosine theta, then your cosine 90°. So therefore in AC circuit, never ever the capacitor consume any power, inductor never ever consumes any power for AC. So only power consumption is by the resistor. So that's why if you know what is the voltage here, and then V square over R, V square over R. Therefore, for this three term, if you just know the voltage magnitude, V square over that, V square over that I am doing here alternative, everybody look. For the DC, VDC square over R. My VDC was 20 volt that I got here. Next, half Vn square over R. I am writing in generalized form because I have the in harmonic terms. This is third frequency. So this is single frequency. This is third frequency. So have, what is my V here for second term? 5. You see, 5 is square over R10. What is the third term? Third term is 1. So have 1 is square over 10. And then if you sum up, exactly you will be getting the same result that you got here. So here what I am showing, that either you could do this thing for power calculation or you can do this thing. This is the alternative solution. Either you use this one or that one. Could you follow me, everybody?
Yes.
So here you see, I mean, this part is not difficult. Once you have the voltage and current expression, what you can do, like here I have written down the voltage expression. Once again, you can write the current expression here, everybody. Like you can write down the current expression from here. Like you fully write, IT is this one. Fully you put side by side here at the bottom. I mean, I did not do that because when I was doing by pen, then I was in front of my eye that equation was available. So I did not write, but you can write side by side for better and clear understanding. So then you just compare component by component. If you have IT is that on like 2 plus this number, and then you compare point by point, term by term. So VDC, IDC, 20 multiplied by that, plus go this term and corresponding current term. You look third term, corresponding current term. That's all. The same thing here. You just look for voltage second term, this one, and then the third term. This is the first term. So that's why V square over R, V square over R. And there is just half. That is coming from the basic equation, basic formula. So therefore, I mean, if I summarize, I mean, it is not difficult. Just the thing is that because in the current expression, it has 3 components, you have to just calculate 3 times. That is the meaning. So first, once again, everybody, first I am writing, I am generalizing. What is my generalized voltage expression? And then I am looking this 3 times and I am assuming that this is applied here, then what? This is applied here, then what? And the third one, then what? And that thing I am doing 3 times. For DC component this, for second component this, and then for the third component this. And then I am just summing up all 3. I am converting into time domain. That's all. So therefore, I mean, so far we consider only one time here, like it depends on the how many terms are there. Now, like once again, if you see there are 5 terms here, then 5 times you have to do. For example, this plus this plus this plus this. There are another 2 to 3 terms. Then as long as you are done all term, you have to keep going. Like, okay, omega is 5, for example, omega is 7, omega is 100. You have to go until that. And then you sum up all those things. That's all. You just have to, now what you have to be very careful. For example, everybody look, what I am saying, okay, you can consider one term, this is one term, second term, third term, but you have to careful about the frequency, omega value. For example, the third term is 6 at an angle of 35. I mean, magnitude and angle has no problem. That you can easily do, but you have to careful about the frequency. Here it is omega 3, but here it is omega 1. So it might happen in other problem that here there is omega 5 and here there is omega 9. It might happen. For example, 5t and it is written here 9t. So therefore, accordingly, when you will be doing this, like today I did, because omega value is 1, so I wrote omega 1. But if you see in other problem, for example, in homework or midterm exam or final exam, it is given omega 5 here. It is written 5t. This means here you have to say 4 omega 5 radian per second, then I is this one. I mean, as I said, magnitude angle is no problem, or whatever the frequency is, whatever the omega is. But you have to carefully look the omega. And what I am saying that it is written 5t, but you did not consider or you forgot to look, you thought that, okay, omega is 1, or you wrote wrong thing, omega 9. Then you will be getting whole thing wrong. Therefore, when you are looking magnitude angle, you do that, plus carefully look what is your frequency. Is it third harmonic or fifth harmonic or seventh harmonic, 11th harmonic? That is the goal of that Fourier. That I have this term, in this case omega 1, here I have omega 3. What is my corresponding result here? I mean, why this thing in like electronic circuit, control circuit, communication circuit, in real practice, this type of situation arises. Always frequency is not the 60 hertz. Frequency may have different, and there can be the DC offset that like Julian said several minutes ago, that there can be the DC offset. So that's why for each case, for each term, you have to know across any specific branch what is that voltage or current or what is that power. And then you may need to pick up for specific. You will have a lot of controllers in real practice, in communication network, in filter circuit, in aeroplane, and you will face this type of situation. You have to pick up one thing, either this or this, depending on the necessity of control. That is the objective of this type of calculation. Hey, now in circuit class, with the help of Fourier series technique, you know the technique how to do that. And then depending on the control situation, okay, I have 3 terms, but I need only this term. You pick up that term. Your controller will automatically take this on. Or you need this component. Your controller, that is the thing we are doing now. We are now learning how to apply the Fourier technique to decompose the circuit and accordingly calculate the voltage and current value or the power value. So that like in the future, you can apply this technique to some control problem. Is everybody fine? Could you follow me?
Yes, this is better than what yesterday was.
Yeah.
Or last class.
Yeah. So therefore, everybody, please once again, look carefully these things. Everybody, once again, from the beginning, you start. You start looking carefully everything. I mean, everything I have written. Then you will be getting. Now, of course, it is a little bit difficult than those like simple phasor things. But if you carefully look, you will not feel any difficulty. Everybody, please look carefully. Like previous, I think we did 2 problems, and then you look this on and then this on, you will be fine. And then here after that, I have just sample. Just I'm saying, okay, if this is the function, you say it looks like rectangular or square, whatever you say, this is E square. Find the Fourier series of the square waveform in the following figure. So like, I think you can do that. This is simply Fourier expansion. Find out A0 value and AN value and BN value. So therefore, I did sorry, yes, I did here. This is the result. Everybody you see that you are getting. And then I have used another function, triangular waveform. It is called sawtooth triangular waveform, sawtooth waveform. Then what? You see, I have done for you. So therefore you look. And then at the end, again, I have done another problem. If you apply this sawtooth waveform in this circuit here as input, what should be your V naught? That thing I have done it here. So therefore, everybody you look in advance, and then again at the beginning of next class, I will ask you whether everybody has understood or not. So is everybody fine? Yeah. I think in signal class you have done this type of thing, right? Fourier series calculation for square waveform or what is that? Sawtooth waveform. So have you all done these things in signals and system class?
Yes, we have.
Yes, yes,
Yeah.
yes. I think you did this thing. What you did not do, I think you did not do this type of application, right? Yeah.
Correct.
Yes, yes, yes. So here, that is the thing we are doing because this is circuit class. We are applying the concept of Fourier series into the circuit problem. That is the thing we are doing. So that's why, again, like in previous two slides, there are two examples. Everybody see that Fourier, how to do that. And I have done, you already know, just see my calculation and image. And then everybody here, this is also solved here. If this function appears here, this means this is the result of the previous problem. Actually, this is the result. This function appears as input to the circuit. Then what? Then what is the value of it? That I have done here. So everybody see this one, then I believe you will be fine. So therefore, everybody please be a little bit attentive and careful, and please have patience. Then I believe you all will get it. Okay, so does anybody have any questions, comments? So if no, then I'm stop sharing